Hey there, everyone. This is your adrenal gland endocrine lecture. So today we're going to go over the adrenal glands, which are probably one of the more important endocrine glands that we have when we're trying to speak about exercise in our endocrine system. So let's take a look here. Our adrenal glands are used in our fight or flight. So if you recall, our sympathetic nervous system will also tie into this discussion a little bit. But we're just trying to get the body ready to do physical activity, either in a stressful situation, whether we have to fight or flee. Um, this will help us. And we'll see a photo of this in a moment, but the adrenal glands sit on top of both of our kidneys. We have two kidneys, we have two adrenal glands, and one of the components, as I mentioned, for how the adrenal gland hormones help us is one through high level performance. So really, that's just high physical activity demands, whether it's say like an elite athlete or a hobby athlete or someone just engaging in health and fitness. But the other component that these hormones will influence is recovery from exercise stress and exercise. And the I'd suggest one of the ways to think of it that way is that a lack of adrenal hormones present in the body will promote recovery. So, just to speak to that briefly, when we were speaking about cortisol previously, that's an adrenal hormone. And again, to decrease levels of cortisol will increase our recovery. Okay, and there's two components of the adrenal glands, the medulla, which means the middle, and the cortex, which is the outside. And this is a bit of a busy schematic or diagram, but we can start by understanding the adrenal glands before we even start exercise. So when we start thinking about exercise, what happens is we cue up our sympathetic nervous system. So we get a nerve signal or originating from our central nervous system to the medulla of the adrenal glands, and our hypothalamus will send a signal to cue on pituitary to release ACTH, and that will head to the cortex. Now, both of those signals will have farthering recruitment of hormones. So we have epinephrine coming from our adrenal glands, as well as corticosteroids. So cortisol being the main one, or sorry, corticosteroids. So cortisol being the main one. And then that goes to the liver to release more glucose in the blood, and epinephrine will increase our heart rate, our breathing rate, and start getting our body ready for exercise. Okay. So once we get exercising, our anterior pituitary will cue up the adrenal cortex, which will further release corticosteroids, which will help get the tissues and cells ready, help generate new glucose through glucogenesis, and will help maintain energy levels while we're actively engaged in exercise. So both before and during exercise, the adrenal glands are really important. And again, I find this a little maybe busy or whatever, but all this part of the diagram is trying to show you is here's a kidney and this is where the adrenal glands sit. So that's the adrenal gland and that's an adrenal gland. Okay, so there's the overview of the adrenal glands as a whole, more specifically getting to the medulla or middle of the adrenal glands. It's wrapped around by the cortex, which makes up about 10% of the adrenal mass. It releases catecholamines. Catecholamines are epinephrine and norepinephrine. And again, these are the hormones or messengers that are going to get our body ready for exercise by releasing energy, so both glucose and fatty acids. but also helps with our cardiac response. So vasodilation in small arteries and veins, and that helps increase blood pressure and therefore cardiac output. Okay. Yeah. If we continue on looking at epinephrine a little bit, we'll see that as we get towards our maximal level of exercise, we see this exponential dose response from epinephrine. So what that means is after a certain tipping point of intensity, we actually see this exponential growth. So it's not linear. On a graph, it would be curved upwards. The release of epinephrine coincides with opioid peptides. So we spoke about those previously, like the endorphins that help us decrease pain. So there's a very strong link between epinephrine, our intensity, our force production, and the higher intensities of this, and therefore higher concentrations of painkillers, natural painkillers in our body. So really tied to intense exercise. Okay. So yeah, about 50% of our VO2, we see a significant increase and exponentially to our max levels. Okay, so that was the medulla or adrenal medulla. Now adrenal cortex, so the outside wrapping, if you will, primarily releases cortisol, right? So our stress, what's typically thought of as our stress hormone, and I would say it's probably considered the most important catabolic, so the most important hormone in our body that breaks down things. And in particular, when we're exercising, this is good because we want energy to be broken down, to be made for energy, right? So there's that point. So glucose metabolism in particular is where we see a lot of that. High intensity exercises, again, this is going to increase with intensity, but again, just through thought alone, we can increase the release of cortisol through mental stress versus and physical stresses. And yeah, I think an important note here about the anti-inflammatory function is this is good while we're exercising, but again, not so good after, or if it is attenuated for long periods of time. So if we have high levels of cortisol, again, our anti-inflammation process is an immune response. It's an immune function. So having short periods where our immune function is suppressed because we're undergoing catabolic activity, and there'll be some inflammation through the damage we're doing to muscles, etc. So it's good in the short term, but in the long term, we want that immune response to return. And so if we're chronically having high levels of cortisol because of not physical stress, but a mental stress, that will suppress our immune system long term. Okay. Good. So continuing with the adrenal cortex, we also have mineral corticoids, or primarily aldosterone. And this is primarily involved in our water balance in our body, and with that coinciding is our electrolyte balance. This is all done through the kidneys. So I always picture this component of our physiology as a juggling act, right? Where we need electrolytes to help pull fluids out into our urine, but we also need enough to keep proper osmotic levels in our body. And so it's just this constant balance about between water and salt, water, salt, trying to maintain that perfect balance. And that's what aldosterone typically does. And so so it'll do that through retaining sodium and secreting potassium. It helps keep our blood pressure or osmotic levels and osmotic pressure the same. Ideally, it deals with our acid-base balance, and a lot of this is helped through ADH, which we've spoken about before, also called vasopressin. Yeah, and so when we get exercising, we're losing electrolytes and fluid through sweat. And so aldosterone does a really great job of trying to help us retain as much fluid while we're undergoing physical activity. Okay. And yeah, and so that is the adrenal glands.